Okay, so we're going to be revisiting these index laws with algebra. I've done some of these in the previous index laws playlist, but I'm just going to be kind of like bringing in some of the stuff with brackets really, and some of the fractional powers that we've looked at. So I want to think, what's the difference between these things that we've got written here? Well, AB squared, let's have a quick look at what AB squared actually is. That actually means AB multiplied by AB. Now we know that that is A times B times A times B. Well, the A times A that we have here is just going to be A squared, and the B times B is going to be B squared, so it's just A squared, B squared. Well, that's good. It looks like if we have a product, if you have a product, which is the AB being multiplied to a power, it looks like that power there just gets applied to both of them. So if you have brackets with two things being multiplied, you can put that power next to both of them, so that AB to the power of n is the same as A to the power of n, B to the power of n. Let's have a look and see how it behaves versus this A plus B squared. Well, sometimes when people make this mistake, they go, oh great, this is just going to be A squared plus B squared. But actually that doesn't work, and I can show you how that works with some numbers. So if you think about doing, say, 3 plus 4 squared, 3 plus 4 squared, if you do the brackets first, is 7. And so the 3 plus 4 is the 7, so it's 7 squared, which is 49. Now if you use that same pattern that we have down here, which is wrong, you would say that 3 squared plus 4 squared, okay, well 3 squared is 9, so it's 9 plus 4 squared, which is 16, which is 25. And clearly this and this are not the same as each other, so you can't do it in this way. The reason that doesn't work is because when you do A plus B squared, you're actually doing A plus B multiplied by A plus B. The A times the A is A squared and the B times B is the B squared, but you've also got the A multiplied by the B, which is from here and here, and you've got the B multiplied by the A, which is also an A plus B that we have too. So this one doesn't work in the same way, A squared plus 2AB plus B squared. You can't just take the power and put it down in these ones. If you're interested, you can have a think about it with this 3 plus 4 squared. If you do 3 plus 4 and you multiply it by 3 plus 4 in the method we've just done, you get the 3 times the 3, you get the 3 times the 4, you get the 4 times the 3, and you get the 4 times the 4. That's 9 plus 24 plus 16. Yep, that is 49. So it does work when you do this full brackets of expanding. You can't just square those individual parts that you've got there. So if you see anything like this, you cannot apply this law we're going to be doing in the next examples. You have to do double brackets. Okay, so I'm going to do these 6 examples, and then you're going to try these 6 ones down here. So you'll find they're pretty similar to year 1 though. Not year 1, but the beginning playlist of index laws. So I'm going to do both of these to the power of 3, so that's going to be a 3 to the power of 3 and the x to the power of 3, that is 27x cubed. So I'm going to do the 2 to the power of 4, 2 to the power of 4. Remember with the brackets you multiply the powers, so that's going to be x to the power of 8 and y to the power of 12. But 2 to the power of 4 is 16, so it's 16x to the 8, y to the 12. Now we do this to the power of minus 2, so that's 3 to the power of minus 2. And then we're going to have the a squared to the power of minus 2, multiply the powers, that's a to the power of minus 4. And then we have here the b to the power of minus 3 to the power of minus 2, that is b to the power of positive 6. So we can work this out, 3 to the power of minus 2, that's 1 over 3 squared, which is 1 over 9. And if we wanted to, we could even evaluate this one. We could leave it as a to the minus 4, b to the 6. But let's just think about what a to the minus 4 is. So we have a ninth being multiplied by 1 over a to the 4 times b to the 6. So in the numerator parts, the multiplying parts, you've got 1 times b to the 6, which is b to the 6. And in the denominator, we have 9a to the 4. So I'm quite happy with this answer that's in yellow, but also you might want to know how it can be equivalent to this answer that I've got here. Okay, let's try this one. So this time you can have these bits. You might need to have a square root. So that's going to be a square root of 64, then x cubed, and then y to the power of a half times a half, which is a quarter. So this is 8x cubed. You could write it as the 4th root of y, but actually I think it's preferable just to leave it as y to the power of a quarter. This is going to be the cube root of 27, because everything is going to have the 3rd with it. And this one, we might need to remind yourself that the square root of x, you can write that as x to the half. So we just need to work out the half multiplied by the 3rd. We're going to do a half multiplied by a 3rd, that's just going to be 1 over 6. So it's the cube root of 27 and then x to the power of 1 over 6. The cube root of 27 is 3, so it's 3x to the 6th. Okay, this one's a bit more complicated. So we've got the 16 to the 3 over 2, and I'm going to do the 4 multiplied by the 3 over 2. So let's just quickly do that up here where I was doing some other things. 4 multiplied by 3 over 2, it's kind of like a 4 over 1. So it's 12 over 2, or 6. So it's a to the power of 6. And then we've got 3 multiplied by 3 over 2. Well, that's just 9 over 2. So we then have b to the power of 9 over 2. Now the 16 to the power of 3 over 2, remember that the 2 is going to be doing the square root and the 3 is doing the cubing. So the square root of 16 is 4, and 4 cubed, which is 4 times 4 times 4, is 64. So it's 64a to the 6, b to the 9 over 2. Here are the 6 questions that I would like you to have a go at, and you can check your answers against mine in just a second. Okay, so the first one is just going to be a 5 squared and an x squared. We're then going to have a 3 cubed, which is 27. The powers are going to multiply, so you get x to the 6 and y to the 9. Okay, so this first one, 4 to the minus 2, is going to be 1 over 4 squared. We're then going to have a to the power of negative 2 times negative 2 is 4, and then it's b to the power of negative 6. Now, if you want to go a bit further with this, we've got the 1 over 16 being multiplied by the a to the 4 being multiplied by b to the minus 6 is 1 over b to the 6. So in the numerator, this is part of the numerator, you have a to the power of 4 because multiplying by 1 doesn't do anything, and the denominator is 16b to the power of 6. This 6 and b's look quite similar, but it's 16b to the power of 6. Like I said, I'm happy with this answer, but it's good to know that it's equivalent to this one. Okay, so the power of a half means square rooting. So I'm actually just going to square root the 81 to get 9. I'll multiply the 4 and the half, because remember you're multiplying the powers to get c squared. And then we already did a third times a half. A third times a half is a sixth, so it's d to the power of a sixth. We're going to square this one that we've got here, but before we do that, you might like to remind yourself that the cube root of x should be written in index form as x to the third. So the 4 squared is 16, and then you're going to do x to the third squared. And a third times 2 is 2/3. This one is going to be 8 to the power of 2/3. Then we're going to do 6 times 2/3. Just multiply the 6 times the 2, so you get 12/3, and 12/3 is 4. So we get a to the power of 4. And then 2 times 2/3 is 4/3. So remember, for the 2/3, the 3 is doing the cube root and the 2 is doing the squaring. So the cube root of 8 is 2 and 2 squared is 4. So you get 4a to the 4, b to the 4 over 3. So those are the 6 answers for these questions. Now in the next video, I'm going to do some final challenges. We're going to do some stuff going backwards, and then we're going to do some exam questions that go along with them. So the next video is going to be challenge number 1, going backwards. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.